All right, so radicals. A few things before we get into working with these in equations and combining like terms and all that good stuff. When we're looking for any sort of a radical answer, if it's a perfect square, that's terrific. Because then we know the square root of 25 is 5. There's a negative lurking, so we can go ahead and use the negative. Now again, if for some reason there's one sometime that I'm not sure about, and I need a little help maybe, I always can go to the calculator. There's a couple of ways I can type it in, depending on what my calculator is. Here, we actually have a square root button. If you hit second and x squared, and it's kind of cool, they used x squared because it's the inverse of squaring something, that'll get you your square root, and then you just type in the number underneath. Oh, well, that was a perfect square. All right. Okay. And we'll talk more about how you can turn that into its decimal form too, but there's not a calculator I know out there that doesn't have a square root button. So that's one thing. If it's really big, okay, again, I know the negative's going to be there, so I'm not going to deal with that so much. But again, second and x squared to get your square root. Then again, if that negative's lurking, don't forget about it. Don't do it. Don't do it. Anybody happen to know the next one? 30. Square root of 9 would be 3, and we just get an extra 0 on there because of the hundreds. And then they'll do screwy things just to see if you're paying attention. Well, wait a minute. 4 plus 12 is 16. Oh, that's just 4. Duh. So don't let things like having things added. My gosh, I'm doing everything. What am I doing? Nobody telling me. I see how it is. But just complete whatever function is in there. Now, you get to something like 9, it gets a little more interesting. Remember, when you have something like this, I don't have to look at it as 16/25. You can divide and conquer. Look at them separately, and then let them go into their fractional form. Is a much easier way to look at it on these. Same thing with 4/81. Each part's a perfect square, so go ahead and just have it that way. Okay? Don't make life too difficult on yourself. But will they always come out nice? Well, no. So that's why when we talked about knowing your perfect squares up to 12, that's going to help with this, because we're actually going to break these down. Because if I plug the square root of 20 in my calculator, well, unless you have a fancy one that breaks down radicals, and there are a few out there that do, you're going to need to be able to figure out how to break this down, which basically means one of my two factors, when I go to break down 20, has to be a perfect square. Now, if for some of you actually listing some of them out kind of gets your brain thinking about it a little bit, I'm just going to go to 100 for now. We'll go higher if we need to. So I need two numbers that multiply to 20. One of them needs to be in that list. Multiply to 20. Add, that'd be perfect. 4 and 5. Okay, because what I'm doing is I'm actually breaking this down. The square root of 4 times the square root of 5. One of them will be perfect and get out of radical jail with a new identity, the 2. However, the 5 is still acting irrationally, so it must stay in radical jail. So again, on these, one gets out, one doesn't. So let's see. What's my combo for 28 here? Again, yeah, one of them's got to be from the list. And the perfect one, square root of 4, is 2. And then 1 won't break down. It stays underneath. But you always, always, always have to have 1 from the list, because otherwise nothing would break down, and that doesn't help us very much. What about 50? Again, 1's got to be in the list. Okay? 25 and 2. And again, if you're not sure on 1, you can always take this number and divide one of these in and see if it goes in evenly. And in this case, 25 would go in 2 times. 25 is a perfect square. The square root of 25 is 5. 2 is not in the list. 2 does not get to break down. But again, keep telling yourself, one of my two factors has to be a perfect square. So what, oh my gosh, I'm back doing this again. I'm being bad. I keep doing the evens. I'm going to stop now. Okay, to 17 where I belong. You're like, wait a minute, now there's a number outside. Yes, we're only breaking down the number inside. How can I break down 12? 4 and 3. Now here's how this is going to work. And I'm going to show an extra step this first time through. The 3 doesn't get messed with at the start. The 4 is perfect and breaks down. Square root of 3 doesn't. But don't leave it, because now I have two numbers multiplied together that aren't under the radical. So multiply those together. Okay? They can hang out together since they're both out of radical jail. We can't hang out with the jailbird 3. Doesn't work. So whenever you see that number lurking on the outside, it's still part of the problem, but the only part you're breaking down is what's inside. I almost did it again. Almost did an even. Not going to do it. 19. Here's where caution's going to have to start coming in. One thing I hadn't mentioned before that I'll make sure I mention now. When you're breaking these down, make sure you get the biggest perfect square possible. Because sometimes you're going to have options. For instance, on 19, some of you may have gone flying along and say, okay, 4 and 8. Which, I agree, 4 is a perfect square. So you'd go along and you're doing, okay, 6, break down the 4, then you're going along and you get your answer and you're happy and you go on to the next one. And then it gets to come Monday when we're doing answers, and I put up a different thing. I put up square root of 16 is 4. I have this up. And you're like, well, wait a minute. But mine breaks down, and I agree. But here's why you need the biggest one. This 12 square root of 8, if I look at the 8, is there a perfect square factor in there? Yes. Yes, and that's the problem. Because now I got to break this down again. So I've got this 12 out here from when I broke it down originally. But now I'd have the square root of 4 is 2, square root of 2, and I got to multiply them together again. Can I still get to the right answer that way? Yes. But I don't think a lot of you, if you broke it down once, are going to look to see if you need to break it down again. So you really want to think about it for a minute. Am I getting the biggest one out of there that I can? Because if you're not, you're going to end up not quite being far enough with your answer to get to the right one. So just something to ponder. You're like, ooh, we're even going to have to add and subtract these suckers? Yep. Treat your radicals just like they're a variable. So if you had 5x plus 2x, you'd write 7x. Same thing here. 5 square root of 7 plus 2 square root of 7 is 7 square root of 7. Don't mess with what's inside the radical. Treat it like it's a variable, like it's a like term that you're working with, is basically what we're doing there. Same thing on 23. You look and you're like, oh, they're both square root of 2. It's 6 minus 8, though. So it's negative 2, square root of 2. But then, bless you, then we start putting multiple things together. It's like, uh-oh. And again, it's like terms. 75 and 48 are not like terms. I can't put these together right now. But I may be able to in a minute. Let's see if we break these down, if this ends up helping us out a little bit here. How can we break down 75? 25 and 3. And again, my 25 is perfect. It gets out of radical jail with a new identity. 5, 3, still acting irrationally. What about 48? Okay, so 16 and 3. And that's something you'll start to notice with these. What'll happen a lot of the time is you'll get the same number that gets stuck in radical jail, which is cool for us because now when I put it together, 4 times 4 is 16. They're out of radical jail. They can get together. And now I do have like terms, because they both have a square root of 3. 5 plus 16 is 21, square root of 3. Now, will it every time break down where these end up being the same? Not every time. A lot of the time, yes. Every time, not so much. So, I mean, there are some little twists that come, but your first thing is always break down a radical if you can. 27. So, can I do 6 plus 4 square root of 2 is 10 square root of 2? Probably not. Absolutely not. Because again, it's like terms. This doesn't have a square root of 2. Can I break down the square root of 2? No. Okay, that's as far as that one's going. So you do have to be careful. You have to have that like radical, that like term there to be able to work with it. And then the problems that we love the most. Square root and squared are opposites, just like add and subtract cancel each other out. Multiply and divide cancel each other out. So do these, and I'm left with what's underneath. If something's squared, again, it's only squaring what's in the parentheses. In this case, it's just canceling those out, and then I can multiply what's left. Okay, don't distribute that squared to the 2. That's not in the parentheses. Don't do it. But should I on 33? Uh-huh. Now it's in the parentheses. So the squared's going to go to the 5. 5 squared is 25. And it's going to go to the square root 11. But again, here, the squared and the square root just cancel. And I multiply them together. So it's all about breaking down radicals up above, and when you get the squared and square roots just wipe each other out. They don't get along well when they get together. All right, let's see what else we got working here. I think we got a couple more things with radicals to play with. Ooh, okay. Same thing when we're multiplying. If you're outside the radical, I can multiply you together. Oh, I'm doing an even one again. Oh, well. If you're under a radical, I can multiply it together. But once I get here, if I can break down the radical more, I have to. Can we break down the 48? 16 and 3. Nicely done. So I've got 12, square root of 16 is 4, square root of 3. Okay, and I'm set. Let's see here. Oh good, I see both of those. I don't have to cheat again. Okay, you're like, well, these next ones kind of look weird because I can't break down the 7 or I can't break down the 7, so what do? This is a fancy mathematical term we call rationalizing the denominator. And here's how it works. One thing you're not allowed to have in math is a radical in the denominator. It can be up here, just can't be down here. So here's how we fix it. Whatever radical is in the denominator, we're going to multiply both the numerator and denominator by that same radical. Like, now why would you do that? Well, let's see. 5 times 7 would be the square root of 35. 7 times 7 is the square root of 49. Oh, but wait a minute. Square root of 49, that's a perfect square. It's 7. I don't have a radical there anymore. Now, some of you might start to pick up a pattern with this. You're like, so couldn't I just, if I see that 7, multiply that by 7, keep it under here, and lose the radical? Yes. Okay, you can. I just like you to see it the first time, and then you can kind of start making your own conclusions. But otherwise, multiplying through is fine. But these radicals in the denominator will always cancel each other. It's kind of nice. Same thing in 39. You're like, but there's no radical up there. That's okay. The radicals down here still will cancel. Just leave me with 7. And up here, be careful. This is not in radical jail, this is. So the 2 and the square root of 7 have to stay apart, and no, I can't cancel the 7s because, again, you're in radical jail. We do not mix with criminals. That's as far as I can go. And there's even one twist to these. You're like, dang, there are too many twists with this stuff. 41, you're like, well, I just multiplied by the square root of 50. Not exactly. Can I break down the 50? Yep. What's the 50 going to break down to? 25 and 2. So what we're really looking at here is 1, because 1's a perfect square, over 5 square root of 2. You're like, ooh, that's kind of different. The only part that concerns me is the square root of 2, because it can't be there. So that's the only part I'm going to mess with. So let's see, 1 times the square root of 2 is the square root of 2. And I know that this square root of 2 and this square root of 2 here is going to equal just plain old 2. So 5 times 2 is 10. And I don't have a radical in the denominator anymore. Yee. Friday afternoon brain overload. There's lots of little things going on here. So let's see here. Let's keep messing with these a bit. 43 is going to be similar. But again, look to see what you can reduce. Is the fraction itself reducible?
Yes.
Yeah. If the fraction itself is reducible, we'll do that first. And then we look again. We're like, can we break down the denominator? Yeah. 4 and 6. So you're like, okay, so square root of 5. Then we got square root of 4 would be 2 square root of 6. But blasted, I still got a radical in the denominator. Bless you. So I gotta dump it. So let's see what we got here. We got the square root of 30. Again, these 2 square roots of 6, the radicals just cancel and leave me with 6. So 2 times 6 is 12. And I'm good. And you're like, okay, gracious, mercy, enough already. One last part to all this. What happens when I start getting exponents and stuff under there? Well, square root of 36 is 6. Okay, that's easy. Here's our last little trick. There's this little number normally that's outside of the radical. It's called an index. And when you're doing a plain old square root, sort of like squared, imagine there's a 2 out there. Here's how this is going to work. When you get these, we're going to do some basic old school division. I don't know how long it's been since some of you might have done that, especially without a calculator. But here's how it works. We're going to take your exponent and we're going to divide it in to the index. So 4 divided by 2 is 2. I don't have a remainder left. That's all good. That's cool. But what if I do? So like here I've got y to the 3rd. Well, if I divide 2 into 3, okay, it goes in once. Okay, so I got a y. But I have a problem. I got 1 left over. I got a remainder. The remainder gets stuck inside. Like, wait a minute. What? Long division. However many times it goes in, you're indexed into this, because it's always exponent divided by index. If it goes in evenly, everything gets out. It's awesome. If it doesn't go in evenly, that's when whatever the remainder would be, I don't know how long it's been since you heard that word, is going to stay on the inside. So like when I get here, okay, remember that little 2's out here. 2 goes into 5 2 times. I have 1 left over. Okay, So our radical jail is just now a place to put the leftovers. 2 goes into 6 3 times. Nothing left over, nothing to put in there. 2 goes into 9 4 times evenly, but then I have 1 left. And I'm set. So just keep telling yourself, this is just old school division back from grade school. Those were the days when math was easy. So then the last twist we can throw in is putting it all together. 12 will break down. So the 2's here. I'm going to move this way over here because I know I'm going to need room for my variables. All right, let's see if this is kind of starting to click here. What's up with my x's? What am I going to have in each place? If I got x to the 7th, what am I going to have on the outside of my radical as far as my x's go? X to the 3rd, because 2 goes into 7 3 whole times, and I got 1 left over. Because 2 times 3 is 6, plus 1 gets me to 7. Everything adds up. Okay, where my y is going to be? 1 on the outside, 1 on the inside. Because 2 goes into 3 once, and I got 1 left over. What about z? 2 z's on the outside, nothing left. It's as far as I can go. And that's your biggest thing with these, is to just slowly kind of work your way through. That's interesting, I skipped an even. Okay. Let's see here. Do that one, and I think we're going to be all right. Okay, so let's do 51, and then I'm going to see how we're doing here. So break down my number. Again, the perfect square gets its new identity, gets out of radical jail. The other guy, not so much. And then again, just go for it in pieces. So for instance here, 2 goes into 3 once with 1 left. 2 goes into 8 4 times. And index goes into exponent 5 times. They're like, okay already. We get it, we get it, we get it. Because again, this is basically everything that you can do with a radical, okay, with what we've done so far. So, I'm going to take, and actually the other note sheet only has like one other little twist to it, and then I'll be done. I'll be done yammering. So I'm going to switch over to that here for a sec. Because this actually talks about the rule a little bit more. So I take a peek, and the only thing I've got to watch out for here is when I have a positive or a negative working. Otherwise, no worries. So I look at this and I go, okay, over here, wait a minute, what's this 3 now? Basically now, the only thing the 3 is doing is telling us that it's going to be to the 3rd. Now let's do something to help you out here. Because most of you will not have a cubed root button on the calculator. It won't be there. So you know how we just got done saying the rule is exponent over index? If I don't see an exponent here, I assume it's 1. So if I wanted to type this into the calculator to kind of see what's going on here, what I could do is go to my calculator, and if I don't have a cubed root button, I can use the exponent. So I'd have negative 343, but I do have to use parentheses with my 1/3, unless you have a fancy one that goes into fractional mode, and the 84 pluses might. So once I get that, oh, what did I hit?
You did.
Oh, I see what I did. I'm a goofball. All right. Friday afternoon comedy in algebra class, watching the teacher hit the wrong buttons. Okay, let's try this again. That's better. Okay, definitely bottom answer. Much better. because negative 7 to the third would be negative 343 anyway. Okay. But my other thing to watch out for are little things. Like here I see there's a negative lurking, so I'm going to leave that out there. Ooh, let's see if we know our cubes. What do I cube to get 27? 3. And since it's negative, so we'd have negative 3. And how many times does 3 go into 6? Twice. So it's the same rules we had as before, except now instead of dividing by 2, if they put a different number out there for the index, we use that. And negative times negative is positive. So we end up with 3p squared. So then you're like, okay, what else do you got here? Plus minus, what? Okay, don't let that mess with you either. Break down your 48. Just like we've been doing. Oops, let me get the calculator out of the way here. So we've got plus or minus. I got a 4 that got out of radical jail because it's perfect. A 3, well, not so much. And remember, if I don't see an index, it's assumed it's a 2. And now we just go back into the division game. 2 goes into 3 once, and I have 1 left over. 2 goes into 4 twice, I don't have any left over. So the rules are all staying the same. It's just now, when I'm doing them, I might do them with a cube, I might do them with something bigger. So like, let's play with some of the bigger ones since we've been playing with the little ones. Okay, cube here. Now again, if you don't know your cubes right off the top, making yourself a mini list does not hurt. Normally, you probably only need to go up to 5, and you're basically going to hit everything. So here I notice, well, 27 will go in. Because again, I'm not doing perfect squares at this point. There got to be cubes because that's what the index tells me. So the cubed root of 27 is 3. I'll keep the 2 underneath the radical. 3 goes into 6 twice. I don't have any left over. And that big bunch of ugly is the answer. And I think Monday, I think we need to build ourselves a little bit of a chart here with some of these, especially these goofy ones like 5th powers and stuff. You're like, 5th power? You're like, holy cow. How am I supposed to? Okay, that's like the first 3 numbers going to 5ths. So you're like, oh, 32. There it is. So that's just 2. Ooh, now let's see if we got, let's kind of see where we're at again here. Okay, 12. 5 into 12. Where's everything going to go? How many whole times does 5 go into 12? Twice. What have I got left over? 2. 5 goes into 10 twice. Nothing left over. And just some of the weird things that can come up. You're like, yeah, because some of these look kind of odd. Like 12 looks kind of odd. I'm going to kind of work my way back here. Deal with it just like it's a single variable. 3 goes into 27. 9 times. Done. Don't make it complicated. 14. 2 goes into 14. 7 times. I'm good. If it's a decimal and you're not sure, no panic. Just think of it this way. You can either go to the calculator, get a little assistance, but I think some of you, once you see this, will be like, oh yeah, that makes sense. Because 9 times 9 is 81. But again, as you keep doing these, just keep the rules the same. The 256, actually is just going to be 4 to the 4th power. But then again, 4 goes into 12. The part that seems like it would be hard isn't bad. Don't make it as such. And our saving grace at the end, finally, thank goodness, going to need a weekend just after this class, is just reminding you how to punch some of these into the calculator. Because a lot of you, again, don't have root buttons for all these things. So when you're going to plug those in, you're going to use 1 as your numerator, and this is your denominator. So like here, if it's a cubed root, I'm going to do it to the 1/3 power. Or if it's, a root of 4, I'm going to do it to the 1/4. So when I go to plug this in, and any calculator can do it, it doesn't have to be a fancy schmancy one. Just type in your value, and again, when you make your exponent, if you have a fancy fractional one, awesome. If not, just make sure you get that in parentheses, and we're going to 3 decimal places. So 0.37, and when you get to here, remember the number after is determining if this stays the same or goes up. What's this third number going to be? 8. And all I'm doing with all of these as I keep working on them again, when it says 3 decimal places, that means after the decimal point, not just 3 numbers. So negative 1.528. If it's just a regular square root, shoot, then just use the regular square root. 5280. Okay. 72.664. And it's going to be the same all the way through with these. So let's see, one more here. Negative 15. We're doing the 1/3. And again, just keep looking at your index. 100. Index is 5, so we're to the 1/5. 2.512. Now again, Monday there will be some time in here to finish up some stuff. I'm not going to go pile driving along, especially when this whole thing's going to be on the next homework check. But I'd assume coming into Monday, that other sheet's going to be done. Probably some of you, when I'd get stuck, we're probably done with 3/4 of the sheet before we even got done with it. But to get jumping into some of this, and again, if it's a weekend and you don't want to carry the book home, remember that sheet you got back the first day. You've got online access to this book. You don't even have to take the book with you. I'm just trying to see what's coming ahead here. Yeah, I was going to say, because Monday I've got one other thing I want to show you, but like I said, there'll be some time in class to work on this too, and we'll get some answers up for you.